Okay, and I will share a screen. Where's my screen share on this one? There it is. Okay, welcome everyone to the, oops, hang on, not quite there yet. Welcome to the main meeting of the Seattle Robotics Society. Um, Video is provided by Zoom. We are recording this meeting, so if you stay around, you kind of implicitly consent to being recorded. We're going to do pretty much the same old thing we normally do. We'll do a little bit of welcome, some club business, any events of note, today's and future presentations. We'll do the around the room. Short break break will probably be somewhere about 10 to 11. Then we'll have an hour for our presentation. And if afterwards, if anybody wants to hang around and continue to chat, you're welcome to do so. I'm going to have to depart, but what I'll do is I'll switch the meeting controls over to you, and whoever wants to hang out and chat for as long as you want, you're welcome to do so. Please mute your microphone unless you are actively sharing. The Zoom chat can be used to ask questions, make comments, post any links. The chat is recorded along with the meeting video and audio, so we post all of it. So if anything you put in the chat that's a great way to get links and other references out to the group. I'm Lloyd. Most everybody knows me here. Chaz and I have been kind of running the meetings lately while Steve K is off doing a couple other things on Saturdays. Steve is still involved. He's still scheduling the presenters and so forth. I think the plan is I'm running it again next month, and then Chaz is going to take over from July to September. So we just share back and forth. Let's see. Past events. Robot Combat League National Championship was May 10th and 12th. Okay, we also tend to talk about makerspaces. This is the list of the makerspaces in the Puget Sound area. There's actually not on here yet, I don't think. Nope. There's actually one up at the the mall in Bellingham that I've gone to a couple of times. It's a really neat makerspace. So if you happen to be up in the Bellingham area and in the mall there, there's a really neat makerspace in the mall. They'll give you a little tour and stuff. It's actually kind of fun. Okay, events coming up. See the Robot Events websites, and there's also meetings at the Snowco Makerspace. Mini Robothon is going to be held on June 8th. We're having a little glitch with the website at the moment, so if you go there and it's doing something odd to you, we know about it. We'll get it. We are working on getting it fixed. Want to find out if there's any interest in doing another virtual Robothon. That's kind of a format we were doing during COVID. We did a bunch of those. They kind of, seem to kind of, I wouldn't say peter out per se, but people were kind of losing interest a little bit and wanted to go back to in-person things. But our intent is to do, kind of a mix in the future. So people who know me, I am also involved in the Robothon committee. So our next event is Mini Robothon. That is June 8th. That will be held at the First Wa Field House. That's down in Kent. And yeah, it'll be our second in-person event since COVID. So we're going to have the first three build events. So build challenges, build challenge 1, 2, and 3. The Pop Can Challenge is going to be run. And we're going to do, of course, Mini Sumo, which everybody seems to really love. Okay, let's see. We are looking for presenters. If you happen to know of someone who would like to present, feel free to get them in touch with Steve. Just, make the introduction and Steve will get them scheduled. Topics can be pretty much anything you like. We don't happen to have a speaker. We will do an open discussion forum. And, whoops. Okay, hang on. Sorry, too many different screens popping up stuff here. We don't have a speaker. We're going to do an open discussion forum. And that'll just be kind of a hosted and facilitated chat. So if you don't happen to have a presentation, but you'd like to facilitate a chat on one of these, feel free to get in touch with Steve and say, hey, I'd like to talk about X. And we'll set that up as well. The schedule of presenters we have so far. May, we have Camp Peavey talking about Homebrewed Robotics today. Next month is John Davis talking about ChatGPT AI. July is Basics of ROS. August is open, so there's a slot for you. September is the Barn Tech Lab. I've got to find out what Steve's doing with that one. I think that's just online, but at one point he was talking about a field trip up there. And you can see we've got some other slots open. So coming up later today, we're going to have Camp Peavey talking about homebrew robots. We'll do that momentarily. And I talked about post-meeting. Folks want to hang around, feel free to.
That's Peavy. We're the poor Peaveys.
Peavey. Oh, okay. And so this part of the meeting is now around the room. Does anybody have anything they would like to share? So we've got about 45 minutes. I'm hoping some people are online with some various chats. And if not, Steve has left me with a couple of videos we can run.
I've got several things. I've never been to an SRS meeting, so.
Okay, go for it. I'll release the screen share. So if you want to share your screen or something else, go for it. Yeah,
so I'm John Hylands. I live in Ontario, Canada, actually, so a little ways away.
Oh, cool. Welcome.
And I've been building robots for 25 years. Lately, I've been working on a few different ones. The one thing that I've been working on is basically a little wearable thing. I call it a universal robot configurer. A little while ago, Waveshare came out with one of these little 1.28-inch round screens, touch screens with an ESP32 on it. And it turns out ESP32s have this communication protocol called ESP Now. I don't know if anybody here has played around with that at all, but it uses the same hardware that the Wi-Fi uses, but it's a peer-to-peer communication protocol. And basically, if you have an you have a pair of ESP32s and you know the MAC address, you can send a message to that MAC address, and if he's listening, it will get it. And it's just like working over a hardware serial port, except it runs at a megabit and it's wireless. And there's no pairing or setup or anything. You don't need a router. It just works. And so I thought, for one of the robotics things that I'm interested in is RoboMagellan. And I thought this would make a really interesting part of a fail-safe as well as a telemetry system. So one of the things I built into this, in addition to the screen and the software that I'm running, I have a little connector on the side here. And when I'm wearing this as a watch, and I'm just going to put it on here for a second, I can plug in a fail-safe trigger to that. And I have a couple of different ones. I'm not sure what I'm going to end up using in the end. Wow, why is this always so hard to do when you're talking to people?
It's the live demo effect.
Yeah, it certainly is. Okay, there we go. got that. So I have a little wire here, and I plug that in, and goes this way. More of the live demo effect.
Mhm.
Can't seem to get the stupid thing plugged in. There we go.
I have to say
And
it
so-
looks very. I have to say it looks very geeky. I like it.
Oh, it's definitely geeky. So I have two different triggers. I have a handheld one. It's basically just a little push button with a trigger on it, and then it's got the same connector. And I have a ring. These are all 3D printed, by the way, if that wasn't obvious, that has a button on it and a connector. So I think I like the ring better. And so I can basically just slide the ring on my finger and plug this in.
And that's looking really, I like it. That's really geeky.
And now I've got basically a failsafe that can transmit to the robot over ESP now. And while I'm holding this button down, this thing can tell that there's something plugged in, and it can tell there's a couple GPIO lines running on this wire, and you can tell when you're pushing the button. And so I've built a whole user interface on this for different robots that I have. So my Robo Magellan robot, for instance, well, here, I'm going to take this off because it's too hard to hold it so that you can actually see it. But you can see there up at the top, this is like a telemetry screen. It says paused. And when I push the button, it says running. And I let go of the button, it says
Oh,
paused.
cool.
And so it's sending JSON packets to whoever's listening, at the specific MAC address that you configure with this, to your robot, and your robot can send JSON packets back again with data that ends up displaying here in real time. So you can tell what your robot's doing, and while you're walking beside it or 10 feet behind it or whatever, and you've still got a fail safe. So that's kind of a neat little thing. And I've built a user interface system for it with windows, and you can swipe sideways to switch between windows and push buttons and dials and display fields and all that sort of stuff. And so you can have a different setup for each robot that you connect it to. As long as your robot's got an ESP32 on it, you can talk to it. So one of my robots that I am playing with right now is a quad walking robot. It uses Dynamixel servos, and it's got a Raspberry Pi Zero 2W as the main processor. But sitting on top of that, I've got this little board here, which is one of those Seed Studio Zao ESP32 chips, which is connected to the hardware serial port on the Raspberry Pi, and that allows me to talk to it with my little handheld device for running missions and getting data feedback and stuff. I'm also working on let me go grab it here because it's hanging off the wall, a Robo Magellan chassis. This is an RC rock crawler. It's got a Raspberry Pi 4 on it and a brushless motor that comes
What
with the
brand rock
crawler.
crawler is that?
It's kind of put together from scratch. I mean, this is like a hobby grade one. It's not like one of the ones you buy at Walmart. So I mean, it's basically a few $1,000s worth of really high quality components. And I've got a Oak D Light sensor on it. It's got a mast which has well, it's not there now, but I have a 9-axis IMU that sits at the top, and a GPS sitting at the back here. It has a magnetic encoder on the motor shaft, and let's see, I've got a USB hub and a little NVMe SSD hard drive for the Raspberry Pi 4. So yeah, lots of fun. So I'm still working on this one. The walking robot I've had for quite a long time. I think I started working on that in 2015 or something, or whatever. It's been around for a long time, in various parts. So yeah, and I've built lots of other robots too over the years.
Oh, very
And
cool. Thank
this
you. Yeah.
Quick
this
question.
this
Oh.
is open source, the code that's running on it and whatnot. So, and they're really cheap to buy these screens and stuff. So
Yeah. Hey, James,
Uh,
you got your hand up. Go for it.
oh, thank you. I was wondering if anybody was going to notice that.
Yep. I saw it eventually.
Yeah, I got there. I'm just curious on the ESP Now thing. Do you have a heartbeat fail-safe built into that so that if the radio link goes down, the robot stops, or has that not been
oh
something?
yeah,
Oh,
that'll be on the robot side of things.
yeah.
So yeah, I mean, I'm one of the things I'm doing is sending a basically a fail-safe command, and that I'm doing that 10 times a second, and getting sensor data back 10 times a second. And if it doesn't hear from that in whatever configurable time you decide, then yeah, it will definitely stop the robot. But that has nothing to do with ESP Now. I mean, that's just the code running on the robot that makes that decision.
Right. Makes sense. I noticed Kaz has his hand up.
Yep. Go for it, Kaz.
You're muted.
Hey, I was just curious if you have a GitHub that you could link up down in the
Yeah.
chat or something like that.
Yeah,
Sounds like a
if you
lot of
want to
interesting projects.
if you want to see that particular the handheld thing, it's I have to make a real repo for it right now. It's just in. Oh yeah, and the other thing is all of the code running on this is MicroPython. So it's the whole thing is all MicroPython.
What do you use
So
for
that's.
the? Oh, go for it.
I was just going to say that link is where the code's sitting right now.
Oh, cool. Thanks. What do you use for the battery in that? I mean, it looks like basically you kind of made your own little 3D printed case and
Yeah,
like a
so
smartwatch type of thing,
it's
right?
basically something like
that.
this.
Okay.
I mean, this is close. I mean, it's a one cell LiPo basically,
Yeah.
because the screen that you get from WaveShare, it has a USB-C port on it,
Okay.
and so you can just plug in a USB connector and it charges the battery.
Oh, nice. Okay. That's good. Yeah,
So
that's very cool.
that's very handy. So yeah, I mean, parts wise, this thing has, well, here I have another one here that's a little bit smaller, with a much smaller battery, but you know, the board itself is really simple. It's got the ESP32 built into the board. So this thing has, you know, not counting the fail-safe connector thing. I mean, there's the display board and the battery and the power switch, which I've sort of soldered into the positive line of the battery,
Hmm.
and the case, and that's it. That's all there is to it. It's
That's really
very
cool.
very simple.
Yeah. For folks that remember the Pebble Watch, I don't know if anybody here remembers that. You know what? I was actually a Kickstarter backer of that thing at one point. 'Cause
Yeah.
it was really cool. And one of the things you could do, you know, they kind of gave you lower level access to the hardware, although I never got time to play with it. I'm kind of looking at the thing you created there, and it's like, hey, that's back to that level. That looks entertaining.
It really is, and it's Python, so it's really easy. I mean, especially if you're a Python programmer,
Yeah.
it's really easy to use, and you know, it's got an ESP32 S3. It's got 2 megabytes of PS RAM and 16 megabytes of flash,
Oh,
and of course,
wow.
MicroPython, when you install it, creates basically a thumb drive in the
Hmm.
flash, and you just copy your source files over to there. So it's
Okay.
really easy development wise.
Yeah.
You don't even have to, you know, you're not flashing it. You plug it into USB. I use a tool my brother wrote called RShell,
Hmm.
and you can just copy the the .py files. I work in VS Code on my desktop or laptop, and then just copy them over using our shell and reset the board, and boom, you're running your new code.
Yeah. James, I see a hand up again.
I just that reminded me, because that display is used on the badge, which is given out at the Hackaday SuperCon, and it was used on the badge last year, which was a vector scope that they gave out to the people who attend. And,
There's a whole bunch of different variants of this display available.
The reason why I mention it is just because it reminded me that they've just announced the dates for the Hackaday SuperCon. It will again be November the 1st through the 3rd in Pasadena. I know you guys are all the way up there in Seattle, but I cannot begin to recommend Hackaday SuperCon enough. It is absolutely worth traveling down to sunny Southern California in November from Seattle, and enjoying the sun and the company of a whole bunch of really cool engineers and people. I hope to see you there.
Could you throw the link to that in the chat?
Yeah, absolutely. Will do.
If you've got it, that'd be cool. And I'll see if I can maybe get Steve to put it on the. Yeah. The other question for you I had real quick, John, does it have to be MicroPython, or can it be a compiled language?
Well, if you want, you can write whatever you want. The code that I wrote is in MicroPython.
Yeah.
So, I have an entire user interface framework that's all interrupt based and to build up this Windows system, UI components and all that stuff. That's all written in Python. You can, you can buy the board and put whatever you want on it.
Okay. Yeah, that's really cool. Thanks for sharing that. Okay, does anybody have anything else they'd like to go talk about for around the room?
There's the new Atlas. I guess he's electric now, not hydraulic.
Yes.
I'm interested to see the new gymnastics.
So we did a video of that last month, and so far I haven't seen. There was just the one video they released where they kind of show him standing up.
He does the contortionist stuff.
Yeah, that's the only thing I've seen so far. Has anybody seen anything else on that?
No, what I'm really waiting for is the price, because
So
Boston Dynamics is typically.
Isn't somebody pitching a $15,000 humanoid now?
I've seen 15. I've seen 30 for sure. And I do know that particular the Boston Dynamics robot is not a research bot. It's going to be used that way. But we talked about this a little bit last time as well. That particular bot is going to be used, I think it was Hyundai automotive factories. So whatever the price is, it's commercially viable for somebody. Which is, at that scale and with that level of sophistication, that's kind of a first.
Yeah, and of course you can get a spot for $75,000.
Yep.
It's Unitree G1.
Yeah, I saw the Unitree at
$16,000
last year when I went to CES. They were there, and I got to see it a little bit. I don't understand the fascination with human form robots. I just doesn't seem like if you're going to do automation, make the automation specific to the task that needs to be done. I don't know. Maybe I'm wrong on that, but I'm just not impressed with them. They're cool. I'm impressed with them as something cool, right? But not for actually getting work done in a factory. I think it's a promotional opportunity. Maybe it's something to scare workers. I don't know.
Well,
No,
take a look at it this way. Our world has been designed and architected for humans and humanoid people. So building a robot to fit into that world, making a humanoid robot fits in nicely, so you can substitute very easily.
No, that's absolutely true. But factories and automation, you have to do extra work to make them applicable to human beings. if the job is to make a product or to make a range of products, making something that a human can work in and then making a robot that looks like a human is more work than just making a robotic factory that makes that particular thing directly. See what I'm saying?
You see the Ubiquity robot being deployed in Amazon carrying the empty containers. Of course, they acquired the robotic company years ago to do the moving the shelves around. But I mean, it's just picking up the empty containers and moving. It's a conveyance system. But I agree, there's a lot to be done with wheeled robots and so on and so forth before you actually get to bipedal locomotion and that sort of stuff.
I kind of look at it as a stepping stone. You know, there's definitely the cool factor, right? But if you build a generalized, not necessarily even fully humanoid, you know, it could have a wheeled base for instance, but a hand, a gripper, stuff like that that are designed to use human tools. Okay, that robot can kind of drop into any task and be flexible. And then once you figure out you've got it down, then you do exactly what we do now, build a dedicated robot to just do that. But you know, we've been building the dedicated machines for decades. Matter of fact, that was a lot of my first jobs were in industrial automation. Right. So we know how to do that. The problem with the dedicated ones is you build them to do one thing and that's all they can do. And the minute you need to do something different, you know, case in point, how long does it take to retool an automotive line, right?
I think the humanoid form factor, I think, is the long-term goal, but it's not there yet. It's not there yet, I agree.
I kind of look at it as a continuum, right? You've got the dedicated, low-cost, less flexible stuff on one end, and we've been doing that for decades, right? And then at the other end, you've got the humanoid robot that's, yes, high cost, high complexity, but I could drop that thing pretty much anywhere I could put a human, and it can fill in for a while. James.
Yeah, so I hear what you're saying there, but I think you're conflating two things that are different. You're conflating human form versus non-human form with single purpose versus multiple purpose. So you can, what I'm saying is you can make a multiple purpose non-human form robot that's capable of adapting very, very quickly. So as an example, a welding robot on an automotive line can be very, very quickly repurposed to weld a different form of a car, right? So that's not an issue. Same thing with the assembly robots, the robots that are grabbing things and putting them into the cars on the assembly line. They don't look anything like humans, but they can be reprogrammed to do a different job very, very quickly. I would argue that the human form robots are harder to reprogram simply because they are more complicated to program. In other words, you have to be thinking about, you know, where it stands and what it braces itself against and all the rest of this stuff. Whereas the other robot is like, has all of these well-known and well-understood kinematic issues. Now, where I could be wrong, and I think it's an interesting thing, is in retrofitting a human factory to do work with robots. And that's where I was talking about how it's something to scare the workers with, right?
Oh,
the idea is we don't have to install anything in our robot. We can just slowly start bringing in humanoid robots and replace you. And it may be that it's easier to program a humanoid robot. Notice that I'm arguing against myself here. It may be easier to program a humanoid robot because you can do motion tracking on a human and figure out exactly what it was and use that to train something that then programs the humanoid robots. But I mean, still in general, if you think about the number of actuators, the cost of the actuators, the kinematics that you have to do for it, it's extremely more expensive and extremely costly. And I just, you know, I think it's more of a splash than it is a actual solution for things. The bulk of the robots that are doing work for Amazon or in car factories or whatever, and where the investment is going is in, you know, robotic arms or mobile platforms or, you know, things like that.
Yeah.
They're cool, but I'm interested in simpler things.
Well, one of the places that I think the human robots are going to shine is being household servants. Plus, as we get older, notice the gray beard, they're going to be interesting for working with elderly and disabled people. You're going to need that humanoid factor in order to do that.
But you're going to have to work on some sort of robot emotional model for anything that works with people, so that snobs and Karens can make them feel bad.
Oh, absolutely. I 100% agree. And that's one of the reasons I fight against all these regulations, because they say they're not going to allow that.
Yeah. Have you guys seen the ChatGPT 4.0 demo video? Because I think they've got the
Not yet.
sucking up to men thing nailed pretty well. I mean, that thing was just so, flirty and so, oh no, and oh gosh, and just very wow. I'm like, yeah, there's certain types of emotional programming they've obviously nailed.
Yeah, not sure it took a whole lot of research to get on that either.
One of the big problems is recognizing the emotion of the people you're trying to serve. Now, that's an interesting problem. And like I say, with a lot of the proposed AI regulations, that's not going to be allowed.
Mm-hmm. Yeah, I've been trying to get my hands on that video. The video, I haven't seen it yet. People keep telling me there's a free version out there you can download onto an iPhone as well. And I tried that, and all the ones I was getting were, various other ChatGPT knockoffs that are basically an interface to the old, the old GPT 3.5.
And what is the O? And what is the O thing? Is that the letter
Omni?
O, or is the zero?
It stands for it stands for Omni.
Okay, so is that it?
And the idea with the O, and we were talking about this at work this week, kind of how I got into it. The O is basically, it's the multimodal aspect. It's looking at video, it can look at text, you can, it's not just voice anymore. It's multimodal input.
Fascinating.
Yeah. Okay, other topics, or anyone else have something they would like to share? Okay, well,
I had a final comment about the humanoid robots, which is that not only could you introduce them into the factories as a form of union busting, but then you could also arm them to do real union busting.
Yeah.
Yeah, DOD has been after that for a while.
Yeah. Has anybody ever heard of the robot called Eater? EATR? So it was, I believe it was like a Boston Dynamics big dog style bot.
Yes, very scary.
And what they did was they fitted it with a Stirling engine, a combustion chamber and a Stirling engine. And the idea was this thing could go out onto the battlefield and simply mulch, or munch vegetation and down trees and debris, right? And use that to fuel itself. And some general made a comment.
And people, if I'm not mistaken.
Exactly. You no longer saw anything out of that robot or its development chain. It just disappeared. So it's
probably
been around.
It's probably under a much more mundane name.
Yes. Deforestation cleaning bot. That carries an MK or M16.
Environmental renewal bot.
Exactly. Yeah.
Wasn't there a spot out there with a flamethrower on it?
Oh yeah, that was floating around about a week or two ago.
Well, it's been a while, but wasn't there a drone with some sort of rifle or shotgun on it that was controlled remotely over the net?
Yep. Yeah, I think somebody had video of that one time here, maybe. And it always kind of made me wonder, how are you going to deal with the recoil on a drone, right?
Well, I guess you just allow it and then you reposition.
And then, that's what you'd have to do.
Yeah, the granddaddy on that one is the Slaughterbot video on YouTube. You gotta check that out if you haven't. I mean, it is. It's a science fiction short film. I'll try to find a link to it and put it in there. But when it comes to using robots for doing very bad things,
let's not do that. We're supposed to be kid friendly in this one. Okay, other topics. And speaking of videos, I do have a couple of videos here we can do. Let's see. So first, does anybody have anything else they want to share? Make sure we got everybody covered before I jump into default mode.
Yeah, actually, it's software related.
Go for it.
I read a lot of random stuff, but I came across a programming language called Bend, and the idea is that it will allow you to use all of the CPUs and GPUs on your machine to fine-grain parallelize code. It kind of looks like Python by intention, but it can get unbelievable speed ups in performance. And I'm wondering if that might not be something we should look into for robots that have multi-core processors, but you don't necessarily have a lot of coarse threaded things for them to do. So the kinds of things that might speed up would be SLAM or anything that needs a Kalman filter like that.
Yeah. So
what was the name of it again?
Bend, BEND. There's a GitHub
link.
That would be
not on me, but there's a GitHub repo for it.
Oh! This is the language, the new language, which is a front end to.
Yeah.
Oh, I can't think of the name of it. But there's a
OpenCL.
I don't think so.
No, it's they wrote a system for doing parallel processing, basically for allowing the parallel processors to work out on their own what work was ready to be done. And then it was super, super difficult to actually make use of. So then they wrote this language called Bend, and it is used to set up that other system that they'd already come out with. You don't use for loops, for example. You have to use something called a fold.
That's it.
Which you kind of have to wrap your brain around a little bit, but it's one of those kind of things where if you can change the old gray cells, which I find increasingly difficult to do at my age, you can then get really, really fast processing. I'll try to look up the video. I just watched a video on this where the guy took a process that took 10 minutes on a single core linear down to 1.5 seconds when he ran it on his GPU. He had a very high-end GPU with thousands of little side processors. I think he ran it on his 16 core CPU, and the time came down to like a couple of minutes, and then he ran it on his GPU, and it was like 1.5 seconds. So it was kind of a demonstration of how powerful it can be.
Exactly. So the one thing that I haven't seen is what happens with things that are I/O bound, for example. Does it figure out in the computation graph that these things are kind of get back to you later? And it seemed to say that you didn't have any more problems with multi-threaded, locking or mutexes or anything like that. And the whole thing is based on a paper from 1999 or something, or maybe it's older, 97, of this complicated combinator system for manipulating control flow graphs or something. I'm trying to read the paper now.
Yeah, the thing, just a short rant, is the I/O is just the absolute killer. I mean, my favorite example of this is there's all these very low-cost cameras out there, and there's starting to become a lot of opportunity to get into FPGAs, which allows you to do parallel processing. What there is not is any way of getting the data out of the camera on a per pixel basis and into the FPGA macro cells directly. In other words, the camera has to serialize everything, and then the FPGA has to deserialize all of that in order to be able to process the pixels in parallel. Somebody needs to make an FPGA camera, which is a single chip with each macro cell having exactly 1 pixel optical receptor, so that then we can actually apply parallel processing without the I/O bandwidth, bottleneck.
Yeah.
Yeah.
So James, somebody's done that, James. I've seen that, and the other one to look at, and I'm trying to remember the name for it.
Well, if you find that, I really want to see it, because that's something I can directly apply.
Yeah, let me see. Let me look up real quick, and I cannot remember the term for it. But there's another type of camera. It's not raster based. It's they use it in the spiking neural network sense, and I cannot think of the name of it now. Hang on a sec.
That's going to bug you. And in the
Yeah.
meantime, I found that video that I watched on Bend, which I think is it's a good introduction and does a great job of kind of explaining what's going on. And Camp posted a link to the actual GitHub repo as well, which is cool.
Okay, so yep, I found it. It's called an event camera. I'll put a link in here. So what an event camera does, if you haven't messed with one of these things, it actually works much more like the human eye. When a pixel change occurs, right? So keep in mind, when you're looking at something, most of the time, the world is just stable, right? It's, most of the image doesn't change. And then think about the video compression for this. So you don't need to send everything. There's another type of camera called an event camera that only transmits the pixels that change. So you can get very, very high frame rates. Well, let me rephrase that. It's not a frame. You get very, very high update rates. It is not frame-based, like a conventional camera. And if you wanted to bring that into a FPGA for ultra high speed computing, that would be that'd be a platform you could go to. I put a link to the Wikipedia page for an event camera in there. These things are available. They've been available for easy a decade now. I think I first ran into them at ICRA in Seattle when it was here. They were talking about them, and they are a bit more expensive, but I think you can get them now within a reasonable budget. They're not like $10,000 or something. They're hundreds to $1,000 or something on that order for the entry level.
But recognize that if you have a camera on a robot and that robot is moving, every pixel is changing all the time.
Actually, not quite. This is the interesting thing. When you look at the videos of these things on a moving and a blur, what you get is a real easy way to get optical flow and edge detection. It tends to be the edges that light up. So you can basically threshold the thing at some level. I haven't played with one, but I've looked at enough videos of these things. It actually, you have to use a completely different set of image processing techniques, right? And I'm not an expert in this. I've just seen enough of it that's like, okay, everything I know about image processing is frame-based, it's not going to work. But what you get is some of the higher level things in traditional image processing, optical flow, edge detection, things like that kind of come out of these type of cameras automatically. And if you want a frame, then you have to do the work to go put it back together.
Yeah, but what I'm saying is you've got something that's moving, a camera that's moving, the image is changing significantly frame to frame.
Yes, yeah.
Well, the key here is that it changes more on some pixels than it changes on other pixels.
Right.
So what you're looking for is which pixels are changing the most. Give me that information first, and then give me the information on the next most changed picture and the next most changed pixel.
Yeah.
And basically what you can do is kind of just work on it based on that. Actually, the second link that I posted at the beginning of the chat, where I was saying that I very, very, very much recommended this paper. I think I said also this related article. It has exactly an example of this for lane following, where they're looking at how much the pixels change as you go out into the distance, looking at the road. And then what they do, it's just really clever, is they warp the image so that the trapezoid or the narrowing road as it goes off into the distance is straightened out, is flattened out. And then they look for which columns of that morphed picture have the highest contrast, and that is how they can find the lanes and the edge markers and whatever else is straight. And what blows me away is how successful that system was back in 1995, and the fact that these kind of methods, which could run on a freaking Arduino probably or a Raspberry at the worst, are just completely ignored in the hobbyist community. So just really recommend that paper. Sorry.
No problem. Hey, tell you what, folks, we are at 10:52. So let's take a 10-minute break. Folks can continue hanging out and chatting if you want to. I'm going to put a timer up. We'll come back in 10 minutes, and then we'll get the formal presentation started. How does that work for folks? I want to give folks a chance to go take a quick little break here before we get into everything. Okay, and yep, I'm going to share the screen to the timer, but go ahead and keep chatting or do whatever else you would like to do for the next 9 minutes and 45 seconds. Sorry, folks, I had the timer on the wrong shared screen.
That's weird. I was able to see it. Now it's on Hackaday.
Oh, then I did have it right. I'll put it back. Just my display here showing, or the way I'm taking is showing which screen I'm sharing is not what I expected, so. Fine.
Yeah, what I can see on the shared screen is your wave share page.
Oh, jeez. I grabbed it and it flipped on me again. Sorry about that. I'm getting a little more, I've got multiple monitors. I'm getting a little more creative with how I use them. And apparently I don't quite have it all down yet.
I shared a link to Teardown. I don't know if any of you have been there before, but it is a hardware hacking conference on the small side, but really well attended. It's in Portland at the end of June, and it's sponsored
cool.
by Crowd Supply. Yeah, and it there's a really nice variation in a lot of stuff that they do. It's not robotics focused, but it is hardware focused. So and last year they brought in an electron microscope, so you could bring your stuff in and look at it with an electron microscope. You never know what they're going to have.
Oh, fun.
And I'll second the going to SuperCon. That was amazing too. So
Yes, behind the scenes where I think I'm not sharing a screen, I'm getting myself signed up for that. If anybody can see that happening, I've screwed up and I'm sharing the wrong screen again.
No, you're good.
Okay, we are back. I had one more announcement that I was supposed to make the earlier session, and it got hidden behind one of my screens, so I'm going to do that now. Steve was Steve was contacted by an organization called Youth for Understanding. They are looking for people to host, basically for, it sounds like, foreign exchange students. If you're interested in doing something like that, please reach out to Steve. And he sent a note around to the whole to the SRS group as well. So just a quick note there to plug that. And with this, let's turn it over to Camp to do Homebrewed Robotics. So go ahead and share your screen or whatever else you would like to do.
Thank you very much, Lloyd. And thank you for inviting me. Let's see here. Why am I not getting that?
I'm seeing your screen okay.
Yeah, I'm sure.
Maximize.
Let's start this again. Thank you very much. My name's Camp Peavey. I'm been building robots for 40 years. I know some of you feed people. These look like some familiar faces out there. I think I went to Robothon back in the 90s or something. I bought Springy Thingy out there, my Burning Man robot. Anyways, this is a great pastime obsession we're all involved in. I'm going to try to share my screen again here. I'm actually using the app. I usually do this on a browser, so it looks different. I'm going to share my desktop. And okay, I get it now. This becomes that. So let's just kick this thing off. I'll stop sharing my screen, and I'm gonna go to the chat, and I'm gonna post some links in here. So the title of this presentation is "The Mock Turtle Bot and Other Robot Odysseys." Okay. Last year, I published a book called Homebrewed Robots, and there's a link there where you can purchase it. That having been said, here's a free PDF. The PDF is better because it has a lot of links, and you can just click on them. And so let's get this party started. I'm just going to go to the PDF and go through my book, and it's Homebrewed Robots. I guess you could call it other robot oddities. Let me get the title of my presentation right here. Okay, I'm gonna do it this way. All right, can everybody see my screen? Yes? Hello, is this thing on?
Yep, looks good. Everybody's on mute. So,
but if you have a question, shout it out. Okay, so let's just move. Let's consider this kind of a discussion thing, so that we'll talk as we go through. So this is Homebrewed Robots. I was born in Tallahassee, Florida, and if I'd graduated on my degree is marketing, Florida State University. If I graduated on time, I'd have hired on with the local newspaper and sold advertising, and my life would be so different. Okay, my last presentation was on Apple Computer. They were coming out with the Apple III and going public, and I thought, ooh, that looks interesting. I'd like to get involved. And I hired on with the Radio Shack Computer Center on South Monroe Street. And that's made all the difference. I picked up a book, David Heisman, How to Build Your Own Self-Programming Robot. Spent about 5 years trying to build that 8085 microprocessor controlled device that you programmed in binary with an 8-bit data bus and a 12-bit address bus, and you loaded in 1 byte at a time. I eventually got his alpha level machine intelligence running on a PC clone with a Relay IO card, and that was one of those eureka moments. Anyways, we'll talk about chapter 1. That's the Protobot. This is just a simple Arduino robot. Bump and go kind of thing. And then the TableBot. TableBot's a challenge we do with the Homebrewed Robotics Club. In 2003, some of us were lamenting the lack of building going on in the club, and we noticed that building spiked with contests, line following, maze busting, that kind of thing. But the contests always had these fixtures that had to be stored, and There were winners and losers and all that kind of stuff. So we were in the Cupertino library at the time, and we thought, let's do tabletop soccer. We could put nets under the table to catch the robot if it fell off and this sort of stuff. But it's like, no, that's setup. That's something you'd have to stage and store and all that kind of stuff. And that's when it was born, the TableBot. TableBot is a robot that survives, lives, and plays on the table or pays the price. And how do you get to tabletop soccer? You do it in phases. Phase 1 is just to go from one end of the table to the other and back. Phase 2 is to push a block off the edge of the table. Phase 3 is to move the block into a shoebox mounted at the end of the table. And it ended up being a great example of subsumption architecture, where simple behaviors stacked on top of each other gave the illusion of intelligence. Not to mention, it had a little juice to it where the robot risked falling off the table and breaking. It was always said about Lego robots, they don't break, they just come apart. But then we established the level 4, where it's okay to fall off the table. The robot just has to keep running when you put it back on. So there's a robustness element to it. You could actually do phase 4 before phase 1, 2, or 3. Machine intelligence. This is David Heischerman's How to Build Your Own Self-Programming Robot that I had attempted in the 80s. It's like, okay, being in the microcomputer business, you look at this stuff and you want to go to the nth degree. I mean, this is the 80s, 20 years ago, right? The nth degree, these mobile robots are computers with eyes, arms, and legs. And so, ever since selling, computers in the 80s, I've always been focused on robots as the next step. And it's a long time coming. Here we are, 2024, right? We're the flying cars, we're the robots, but therein lies the opportunity. I think that's why a lot of us are here is, it's obvious what's coming up. And once it's all nice and clean and smooth, all the goodies gone. So, our timing is good because there's a lot in this space that needs to be designed, manufactured, sold, used, et cetera, et cetera. Robo Magellan trials. I've run the Robo Magellan event at Robo Games. It must be 10 years now. I actually got a bronze medal in 2012 where I touched the gold cone in competition. That rarely happens. It's like hitting a hole-in-one with all your friends around. But it was funny because it was just pure GPS, which gets you plus or minus 12 feet, right? But on this particular day, Blue Dog lined up, went to the gold cone, and I was having trouble with the center sensor, ultrasonics, and so I disabled it. And if the sensor had been enabled, he'd have gone around the cone. But on this day, it was headed right for the cone. The center ultrasonics disabled, and it hit the cone and stopped. I almost fell over. There were like 10 other competitors behind me, and some of them were pretty good. I was worried I was going to lose my bronze medal, but I ended up getting a bronze medal. And, bronze is the happiest medal of all. Next chapter is on ROS, Robot Operating System. I assume you folks are familiar with ROS. ROS is a standard framework for robotics. I was at Nito Robotics for years. The Nito robot, let me back up 3 steps. I spent some time as a network administrator and was locked in a server room, forced to learn as much Unix as I could stand. And then in 2010, when I was at Nito Robotics, we made a robot vacuum cleaner with a LiDAR, 2-dimensional LiDAR on it. Mike Ferguson made the Nito package in ROS. And so that's when I learned about Linux, and it's like, oh, VI, my old friend, I know this. And so it's like, it's really nice. I like Linux because it takes me back. And so the next chapter is on the Nito Turtle. That's where we put a Raspberry Pi. Actually, this chapter here is about making a Linux workstation and installing ROS. There's a lot of ROS things that can be done, tutorials and stuff just on that. But then you use that workstation with the Nito Turtle. You're putting Ubuntu and ROS on a micro SD and booting a Raspberry Pi. You put the Pi in the dirt bin of the bot vac. It has a little micro USB port so you can drive it and read the LiDAR scans and stuff like that. So it's been ROSified so you can do mapping and navigating and all that good stuff with the Nito. And originally, I would like Velcro a computer on top of the robot and drive around, make maps and navigate and stuff. But with the Pi, like I say, you just take the Pi and drop it in the dirt bin, and it makes a really good system. I'll show you more about that later. Then Smarty Head is a superstructure that I put on top. I basically used the original TurtleBot superstructure. We homebrewed a Ross 2 ultrasonic sensor. I swear there was none out there. And so it was really cool. We took I host a Ross discussion group on Tuesdays, by the way, and I'll put a link up. I'll put it up now for the Homebrewed Robotics Club. And I host I just joined the Robo Magellan, the Seattle mailing list, by the way. So looking forward to some of that. But I host a Ross discussion group on Tuesdays, and it's a really good group. Let me put let's see, I've got some kind of link I want to put in there. Let's see here. There it is. Let's see here. Okay, I'm putting a link to the Homebrew Robotics Club. hbrobotics.org. Boom. Yeah, so didn't make it into a website, but you guys can copy and paste. I spelled it right, didn't I? Yeah, so our main meetings last Wednesday of the month. And like I said, we meet at In Orbit in Mountain View, but we also meet on Zoom. Chuck Pitzer is our next presenter. He's going to be at In Orbit. I worked with Chuck for years at Nito Robotics, and he went to Fetch Robotics, and they got acquired by Zebra Robotics. He's there now, but he's also famous for BattleBots and the Ghost Raptor and all that kind of stuff. So Chuck Pitzer is going to be our presentation. We have show and tell, and like you guys, we have club news and industry news and so on and so forth. Let's see now. I want to go back to. Where's my PDF? That's not it. Sorry. Okay, yeah, here we are, back to the book. Okay, and then looking forward, just has some looking forward stuff. So moving right along. Again, this is my Silicon Valley story. I've just mentioned it is selling computers, building robots as a hobby. This is the book. You probably recognize it. David Heisman wrote a lot of robotics books back in the 80s. This is a great one because not only did it have this mobile robot, he included an early theory of reinforced machine learning, where the robot's goal in life was to move. And you'd switch them on to do random motions with differential drive system. With differential drive, you have 9 different motion patterns: forward, reverse, clockwise, counterclockwise, left wheel forward, right wheel forward, et cetera, including stop. And so as long as the robot was moving, it was happy. When it stopped moving, it blocked, it would generate a random code to produce a new motion pattern. And if that was successful, it would increment the probability. If it was no longer successful, it would decrement the probability. And thereby, when the robot encountered, he had 3 levels of machine intelligence. I'm getting ahead of myself here. Why not? So this is the machine learning chapter here. Yeah, here he goes. And so this is my original Rodney here. This is the 8085 microprocessor controlled device. We program it in binary. It's got relays down here and stuff. Good times. I spent about 5 years trying to build that. Eventually got the machine level, got the level 1 machine with a store-bought IBM PC and clone and a Relay IO card. But the concept here, then this is my fighting robot. Highlight of my life, I won the 96 Autonomous Robot Wars. Great thing about robot autonomous is you're 1 of 2, so you automatically make it to the finals. And with a little bit of luck, I was going up against a guy named Smart Spike. He veered off to the right and got disabled on one of the traps. But what you have is this infrared transmitter on the robot, and I used television remote control receivers for eyes. When the left wheel saw the transmitter, the right wheel went forward. When the right eye saw the transmitter, the left wheel went forward. Both eyes saw it. It would lower the flipper. I later put a chainsaw on it. Initially, I didn't have a chainsaw, but I managed to mount an attack on the opponent, and I got the $200 cash and trophy, and that's the highlight of my life. But anyways, with David Heiserman's machine intelligence theory, there are 9 possible motion patterns in differential drive. He had 3 levels. First was alpha, which is random. Second is beta, which had memory. And third was gamma, which had an element of generalization to it. So when the robot moved and encountered a stall condition in alpha, it would generate random codes to do something to eliminate the stall condition, okay? Strictly random, not much intelligence going on there. In the beta model, when the robot encountered a stall condition and tried something that was successful, it incremented the confidence level of that response. So the next time it was in that motion pattern, it would try that response. If it continued to be successful, it would increment its confidence level. If it was no longer successful, it would decrement its confidence level. And so there you've got memory learning going on. Now, in the machine level 3, it would generalize, where when it encountered a stall condition for which it had no high confidence responses, it would revert to high confidence responses from other motion patterns before reverting back to random motions. And so there's a very simple lesson in reinforced machine learning. Here you see Rodney Jr., which was the David Heiserman book, on an Arduino. And I actually applied that to Springy thingy. That's my dancing Burning Man robot. This is Red Dog here. This is Rusty. That's Rusty before it became Red Dog, the Robo Magellan robot. Anyways, I'm getting ahead of myself. Let's back up a bit. Questions, comments, complaints? This thing on? You guys still out there?
Yep, we're still here. Just everybody's on mute. I actually read the book you mentioned. I'm actually pretty sure I read that one as a kid.
Yeah, David
Heiserman.
He wrote a lot of those. Along with, who's the fellow that did the Robot Bonanza? Malcolm. Can't quite think of his name now, but yeah, those 2 guys. So let me get back here and moving ahead. Okay, so. Yeah, so, okay, the Protobot is just a simple, here's me at Burning Man with Springy thingy, my art robot. After doing the battle bots, I had a Piranha bot. This was a more peaceful endeavor, and we had a lot of fun running the robots out at Burning Man. It was so cool. The goal was to leave the event with a functioning robot, and we went from 99 to 2005. So we went 6 for 6. We'd leave the event with a functioning robot. Burning Man is too much of everything. Okay. And so, I did 6 years. I had a good time. And it was fine. I'm done with Burning Man until 2018 when their theme was iRobot. And I'm like, damn, Burning Man, what the hell? And so I had to go because I didn't want to ask why I didn't go. But I'd forgotten how much fun it was to drive the robot around out there and stuff. And so we went in 2018 also, and it was awesome. So here's talking about the Homebrewed Robotics Club. You guys join the Homebrewed Robotics Club mailing list too. It's a pretty good group. And come to our meetings last Wednesday every month. Like I said, we've actually got some SIGs, some special interest groups, a voice intelligence group, a ROS discussion group, and the penultimate Wednesdays we do Builder SIG, where it's just random access robot building, show what you're working on, that kind of stuff. So here's the story about the TableBot challenge that I mentioned earlier, where the robot pushes a block into the shoebox mounted at the end of the table. That's actually a Robo Magellan event. That's actually a Robo Games event now. They do it. They call it tabletop navigation. Yeah. So here's a picture of Robo Games, Robo Magellan. You guys event. We've done Robo Magellan for years also. I think it's fantastic because it's a full-scale robot, does an actual useful application. I think a robot that can get to a particular GPS coordinate is pretty amazing. we take a lot of technology for granted, but it's pretty darn amazing. And yeah, without being a fighting robot, it's a full-scale robot, does something useful. It's not a fighting robot. In 2005, I got laid off my nice cushy network admin job and decided to start a business selling robot kits. And I'm proud I sold a couple of dozen of them, but I quickly realized I'm not going to make a living doing this, and went back to work at Jameco Electronics, and eventually found my way to Nito Robotics, where we built a robot vacuum cleaner with a LiDAR. And that was a super fantastic experience. So here we talk about the Protobot. This is a simple Arduino. Kids interested in robots, this is a great place to start. Homebrewed, no less. It's not like a finished kit. And so you're taking an Arduino and servos and bump switches. Actually, this is, I like this, it gets you started from nothing. Okay, say, like Vince Lombardi, this is a football, okay? And then we've got a servo, okay? And then explain how you wiggle the wire. You wiggle it 1 millisecond, it goes one direction, 2 milliseconds, it goes to the next, 1.5, and it stops. So that's how you control a servo with an Arduino. Okay, and then we get into a little bit of code here, and talk about the Arduino again. And so here, this is what I call a homebrew plug. You cut off the end and you put 22 gauge solid core wire, so you can plug it into the solderless breadboard. And the library servo, talk a little about solderless breadboards. I think those are underrated. I've built robots for years using solderless breadboards, even out on the Burning Man Playa. They work fine. They didn't never go out on me. And so, yeah, I like this little drawing here. It's kind of cute. Voltage and resistance are jerks. Serial monitor, that's a useful thing on the Arduino. And so, see, at some point here, yeah, output, input. Okay, so the point is, if you go through this chapter, with somebody who's a beginner, it's like out of the box, we get a servo moving. Oh, wow, look at that. Make it go back, forth. Okay, and then you add a switch, and with the servo monitor, you see the switch turn from a 0 to a 1. Okay, I got output, I got input. Okay, now let's put it together where you have output, input, and reaction. So, I'm outputting, the motor spinning, and when I push the switch, the motor stops. Wow, okay. At this point, you're on your way to building robots, right? Not too far to, okay, let's strap 2 of those servos in the bottom of a round circle, acrylic, okay, and hack Instamorph. Instamorph is great if you don't have a 3D printer. This is a thermal polymer. It comes in little beads. You put it in a bowl with water. You microwave it for a minute or 2, and then you can mold it into whatever you want. And when it cools, it becomes hard plastic. So Instamorph, I recommend it. So I made a little tail thing there with the Instamorph. And so, here again, you've got your Arduino, you've got your 2 switches, and you've got your servo wheels. You glue it all together with E6000 or 5-minute epoxy, which takes 10 minutes, but hey, it's great stuff. And so here's code. I'm driving, I'm bumping, I'm moving back. And so here you've got a simple bump and go robot, and that's the starting place. Beyond that, we go to the TableBot. I told you the TableBot story from the Homebrew Club. Build a robot that survives, lives, and plays on the table or pays the price. So I put drop sensors, and I have 2 ultrasonic sensors, one low, one high. The low one detects the block. The high one detects the box. As soon as I've acquired the block, I move it into the box. And I participated in tabletop navigation at Robo Games this year. Tabletop navigation. I didn't get a medal in it, but I didn't embarrass myself either. I did 2 phase 3s and a phase 2. I did no phase 4s. So that's the good thing. Let me show a video at this point. Let's see here. I don't know if I've got the audio going through, so I'm just going to narrate it. Yeah, here's a tabletop challenge video. Have you guys heard of the tabletop challenge?
I haven't.
I had not
That's
either,
kind
but
of a neat one. Yeah.
it sounds very convenient and fun, especially for, like, I'm a father and my daughter is starting to quasi show interest, and so I think that sounds like a much safer place to start. Where's the narration? You're muted, Camp.
Oh, you probably don't have the audio pipe through. When you share, there's a button to pick up the audio.
So it looks like there might be tiny actuators, or is that just a catch bucket on the front?
Camp, if you're talking, we cannot hear you.
So sorry about that. I went through that whole thing. I was trying to talk about it, but I think you get the concept.
Yep, we can hear you now.
Yeah, I don't know when the audio went off. Could you hear any audio?
Right about the time you started the video, I think is when we lost you.
Was there audio coming through for the video?
No.
Fascinating. Okay, so they muted me while I showed the video, but they didn't let the audio of the video go through. Okay. Regardless, what you saw there was the table bot challenge. We've done it for years at the Homebrew Club. We want to show your robot in its best light. You can bring your own table. You can bring your own block. You can bring your own shoebox. I've seen some awful big shoeboxes in my time, but it's not a contest. It's a show, and you get there in phases. Phase 1 is have the robot go from one end of the table to the other and back. Phase 2 is have it push a block off the edge of the table. Phase 3 is have it move into a shoebox mounted at the end of the table. And so in our club anyways, you can walk up to a table with your robot and say, I'm doing phase 1, 2, or 3, and everybody knows what you're talking about. When it falls off, they'll say, oh, that's a phase 4. Anyway, so we have a lot of fun with that. Let's go back to the book. All right, I'm not muted now. Okay, that's good. Thank you. Okay, so this is Rodney Jr., the machine intelligence robot that I mentioned earlier. And basically he's monitoring a little encoder wheel. Yeah, there it goes with the Roomba. And so, something I realized with Heiserman's original model, I think he had a swivel wheel back there, but it's like it would detect motion even if it was going clockwise, but really isn't fair because that has no linear velocity. Okay, so the cool thing about this Roomba wheel is it does not spin unless the robot is going forward or reverse. The only two motion patterns with any linear velocity. So, clockwise, counterclockwise, left wheel forward, left wheel reverse, right wheel forward, right wheel reverse. It's just angular velocity. It's not going anywhere. And so with the Rodney Jr. here, it would only detect motion when it was going forward or reverse. So it makes for an interesting demo where I'll switch him on. And, at first he's just kind of randomly spinning back and forth. And then from one motion pattern or the other, it'll discover forward or reverse. Okay. And then from there, it really only needs to discover the opposite of reverse or forward before it's going back and forth. And although you look at it and you scratch your head and go, so what? I have to point out that it's not that the robot's going back and forth. It's that the robot learned to go back and forth. That's the point. And so, yeah, that's Rodney Jr. And that's basically an Arduino-based David Heisman, how to build your own self-programming robot. And so there you see the alpha code where it's random response. And then you got the beta code, which is response of when you're in a motion pattern, a high confidence response, and then the gamma mode, which generalizes. When I'm in a stall condition and I don't have any high confidence responses, I go to high confidence responses of other motion patterns before reverting to random motion. And so that's David Heisman's How to Build Your Own Self-Programming Robot. Or that's Rodney Jr., which is a Arduino version of the same. Hooray for arrays. Yay. And so here's chapter 4. Here's one for the Seattle Robotics Society. Robo Magellan Trials. You guys created this contest in 2004. And like I mentioned, I think it's one of the best because it gets you off the table, full-size robot, useful application. You can get within 10, 15 feet of any spot in the world. GPS is, I think GPS is one of the most underrated sensors in mobile robotics, even indoors. I drilled down on the Google app and I could see myself walking from room to room. I think it's the solution to kidnapped robot. At least it tells you what room you're in, and then the robot can look around and figure out where it is within that room with other sensors. Here's my here's the proof. Blue Dog headed to the Gold Cone in 2012. It was even better than that. This is at the Alameda County Fair, and there was a cheerleading group there too, and Tony Pratt-Canis Sr. had them cheering, "Go Blue Dog, go! Go Blue Dog, go!" I mean, I was in like a dream state there. I couldn't believe it because, like I say, this doesn't have the camera. Generally, and you guys know this, you got a GPS to get you in the ballpark, and then you have a camera to guide you into the OSHA orange cone. And I hadn't quite got the camera going yet. But on this day, the robot gods looked down and smiled upon me, and I managed to touch the gold cone and get a bronze medal. So I'm going to build. This is me building a Robo Magellan robot. I started off with this one here, but it didn't get any traction off road, and so I reverted to this kid's ride-on toy here, the Huffy Green machine. Okay, and actually, this is Homer on what became Frogger, which was Blue Dog, which was Rusty. You build off what you've built, right? But this is at Burning Man, and I've got the GPS on there, and he's basically traveling north with Homer, the homebrewed humanoid, on there dancing. So that's another whole story. 2 Arduinos in one. So I'm using one Arduino just to read the GPS and relay the information to the Arduino that's controlling the robot, okay? And something I learned about Robo Magellan early on is it's basically a math problem where you have a GPS coordinate target and you have a GPS on board your robot. And all you need to do is compare the GPS target latitude to your actual latitude. If your target latitude is higher than your actual latitude, you need to go north. If your target longitude is higher than your actual longitude, you need to travel east. So now you know what direction you need to go in. You've got a compass on board. You go in that direction, avoiding obstacles along the way. You will eventually get within 10 or 12 feet of that GPS coordinate, at which point you switch over to camera and you're looking for OSHA orange, to drive into the cone. And so, here's some, I think this is pseudocode. So there's the robot there. And I eventually, so that's a map we used in one of the Robo Magellan contests. A little schematic here. I had a CMU cam, and I put it on a little robot and used that little robot to train it on an orange cone. And I basically taped that to the front of the big robot. And the point is that, okay, this big robot gets you to within 10 or 12 feet of the goal. And then the little switch over to the little robot and it'll drive you into the goal. And so, yeah, there it is, homebrewed style. So I've got a little video. Questions, comments, complaints?
Nope, seem to be moving right along so far. So,
All right. So I don't know if okay, I didn't get muted that time.
It's Kermit, my Robo Magellan robot tracking to a GPS coordinate at the end.
So this is Kermit. Kermit.
On
On Kerbit, I believe. Yeah, Kerbit. Get it? That's a pun off of Kermit. And he's looking for the orange cone. He actually is looking for the GPS coordinate. I don't know if I've got the camera on there. I don't think I've got the camera on there yet. Actually, I do have the camera on there.
Give him a little bit of help there.
We'll give him a little bit of help here. I'm not proud. Yeah, I got the camera up there. He actually got to it that time. It was the GPS, it was the ultrasonics. I haven't got the ultrasonics to switch off yet when he gets in the zone. So he's actually going for the orange cone here, but the ultrasonics make him back up.
Got a switch on the front, so if it can touch.
So I've got a switch on the front, so if he touches the switch, he'll actually stop. But the ultrasonics take over before it bumps the big switch. The switches are like a coat hanger on the front. You see that big black thing on the front?
Give it one more try.
This is all autonomous, not remote controlled. Could make him into a lawn mowing robot. I'm not proud.
Not proud. Come on. Oh, all right. Ultrasonics is getting-
Almost. The ultrasonics kicked in again. Now watch this. Can't make this stuff up.
There you go. That's the GPS card. We're actually hugging it.
How about that? He's hugging the GPS coordinate. All right, that's enough of that. Oh, where's that? Okay. So yeah, that's GPS. Okay. So the next one is the ROS operating system. We talk you through installing a ROS is the standard framework for robotics. It was created by Scott Hussein, Willow Garage, made for the PR2, Personal Robot 2. Personal Robot 2's claim to fame is it could plug itself in. It could actually fetch a beer from the refrigerator, our holy grail, right? And it could plug itself in. That's something useful for it could fold clothes too. And of course it'd take it 20 minutes. You'd have to take it 20 minutes to fold a towel, but you could leave it in a room with a clothes basket and come back at the end of the day and all your clothes are folded. But anyways, so it was created, it's open source. It's a publish and subscribe architecture. And I've taken it and applied it, I should say, Mike Ferguson, this is some of the stuff you could do with just the workstation, made the Nito package in 2010, and I've applied it to the Nito bot vac. You can put ROS onto our Raspberry Pi. You can drop it in the dirt bin, and I think it's the best value for mapping and navigating the bot vac. Not only that, it cleans the floor. So yeah, there you made a map, and here I am navigating within the map. So my vision now, and what I'm obsessed with, is something called the smart table. Smart table is a tray table that can reliably get from one place to another. I think that would be useful in the home of the business. And so here I put a superstructure on top of the bot vac. You got to have ultrasonics or something to cover for this middle area so it doesn't navigate under the bed and under the couch. Yeah, there it's got a camera on board, so the things you can do a camera. So we put the camera on there. And here's one that I'm really proud of, the Homebrewed ultrasonics sensor. So when I was writing the book, I couldn't find an ultrasonic sensor for ROS 2. And so what we did was we took the simple publisher in the tutorial that just publishes the hello world text message, and we took a Python program for the ultrasonics that created a variable called distance, which was the measured distance of the ultrasonics. And we displaced this text hello world with a range message so that our sensor would give us the distance in a range type topic, which could be used for navigation. And so let's see, I should have an image there with it in the. So I don't see it there, but yeah, so you can actually have ultrasonics in the middle, and the LiDAR does the mapping, and you use the ultrasonics for navigation and a camera for the things that you would use the camera for, communications, entertainment, and security. And so looking forward, like I say, this is a great business we're involved in, mobile robots. It's nothing compared to what it's going to be. Lino Robot is a good place to go to learn this stuff, and Gazebo and Trials. This is like, okay, so on to my next project. Oh, I know what I'll do. I've got another video here. This is my Nito turtle. This one's a little long, so I'm going to cut through it. And if you actually, I'll put this one in the chat, because this is if you're interested in the bot vac, using it to learn ROS, this is actually a good video to listen to. So I'm going to scan down here. So here you can see the robot. I basically create a map, and then I'm navigating within the map. I'm just gonna put this in the chat. So if you're interested in looking into it further, it's in the chat now. This is all about mapping and navigating with the Nito bot vac. Nito bot vacs could be had on eBay for like $150. All right, and like I say, you do up a Raspberry Pi with Ubuntu and ROS, and you drop it in there, and you can do this kind of stuff where it's autonomously navigating and mapping and navigating. It's a really good way to learn ROS. Let's see here. I'm going to stop this, and let's see. I've got one more. Sorry. Let's see. Again, questions, comments. All right. So this one right now, I really like the Create 3. Okay, Create is from iRobot. It's basically refurbished i3s. But what they've done is they've made this all ROS 2. Okay. And so when you get a Create 3 and boot it up, it launches these ROS nodes and exposes these topics. So you can do teleop twist keyboard out of the box pretty much. I I've got the DL06 LiDAR, which includes a ROS2 package that includes a laser link to, here I've set a pose all the way back in the kitchen. The robot's navigating the entire apartment to get back to the kitchen. But I got the DL06 LiDAR that includes a ROS package that has a base laser to base link transform. So you basically Velcro it to the Create 3 run slam toolbox. You're driving the Create 3 around with teleop twist keyboard, and it generates a map. You save that map, and then you kill Slam Toolbox. Be sure and save your map before you kill Slam Toolbox. Here's another suggestion: is to save it as you go along, because you'll take it too far. You'll think, oh, I can make it a little better, and you'll screw up the map. Make saves as you go along, so that when you do screw up the map, you've got it saved. Once you've killed the Slam Toolbox, and killed the RViz, you'll run the I run the localizer stack out of the ROS2 nav2 bring up, and that launches the map server that loads in the map that you just saved. It loads in AMCL, which is your localizer, adaptive Monte Carlo localization, and it loads in the life cycle. And then you load in the nav2 stack, which has your controllers and your path planners and your recovery behaviors and that kind of thing. And then you launch RViz, and that's what you're looking at here. This is a Create 3. Actually, it has a I've got the superstructure on there from I made it. Let me switch over to my current project. I'm working with some other guys now, and we call it the mock turtle bot. And so let's see here. Are you not entertained?
No, very informative.
This is our current project. This is our mockument on the mock turtlebot. Okay, I think the turtlebot platform is something that has a lot of, how shall we say it, potential. Okay, and that is a smart table, a tray table that can reliably get from one place to another. Okay, and so here we're writing a new book. It's going to be called Mock Turtlebot, and we're going to build the Turtlebot homebrew style in a variety of ways. Okay, and so here's a little about the personal robot, and again, my vision on the tray table, anyways, is the parent can prepare a meal, put it on the mock turtlebot, send it to the living room. Kids consume the snacks in the kitchen, back with leftover dishes, deal with it later. Tray table comes to you when you need a place to put your coffee cup down, or even put your feet up. Have a small piece of trash. Trash can comes to you. Robot walks in the door before you leave with your stuff. I need my computer, my CPAP, my tools, whatever, to come to me. I need my music to follow me around. Artificial intelligence should be proactive and find me when something interesting happens. Eventually, we'll get to pick, move, and place, mobile manipulation. But in my opinion, the starting point is the base and human-assisted delivery, okay? Here we go through some of the personal robots of the 80s. We talk about turtles and why ROS is based on turtle terminology. It has to do really with the turtles all the way down Hindu philosophy anyways. So, and here we're talking about turtle bots. This is just a work in progress, this book, but we got a forthcoming book, like I say, called Mock Turtle. So here we talk about building the ROS workstation, which is something I covered in Homebrewed Robots. Get an old virus infested Windows machine and blast it with Ubuntu. It's great. I get computers from Goodwill all the time and do that. And so there's the talker listener from ROS. But this is stuff you could do with a ROS workstation. Again, I've already covered this in Homebrewed Robots. And again, we talk about making the Pi compute, which we had a little fuss over that. We got to go back to the imager because that'll get you to 2204. You don't want 2404 because the ROS Humble doesn't run on that. Anyways, it's all about the base. So we're talking about making turtle bots with 3 different bases. The Create 3, if you can afford it, $450. I recommend this base to build the robot with. You could build it with a bot vac. Bot vac is arguably the best value because when you buy a bot vac, it comes with the LiDAR. You could get bot vacs refurbished bot vacs on eBay for $150. The Create 3 costs you $450. You have to add $100 for the LiDAR. So again, bot back's arguably the best value. And then we're going to talk you through making it with just a plain Roomba. If you take the top cover off a Roomba, you'll find a little 7-pin mini DIN in there. And so you can hack it and make it to the equivalent of like a Create 1 or 2, and you can build a mock turtle bot from that. So, and then we'll have like 3 different kinds of LiDAR. Oh, the tabletop end effector. So this is my lineup here. This is the Smarty lineup, Smarty 1, 2, and 3. Smarty 1 has the bot vac, XV LiDAR. I've got a Logitech camera and the Homebrewed ultrasonic sensor. Smarty 2 is the Create 3 LD06 LiDAR. And then this one's going to be the Create made from a Roomba. And I'll probably use RP LiDAR. And I will want to use the HP or the Oak D Lite on some of these, and also a PyCam too. And so again, it's like mock turtle bot, build it your own way. We've got 3 different bases. We'll cover 3 different LiDARs, the XV, the YP, the LD. We'll cover 3 different cameras, Oak D, the PyCam, maybe some others have the ultrasonic sensor in there. There's a laser. But again, we're going to be building mock turtle bots. I think that's a great base. Put it all together, whichever base, whichever LiDAR, whichever other sensors you're using, you'll want to put it all together with the SLAM toolbox, the localization launch file, RViz, the visualizer, and we're trying to get you to mapping and navigating. And then looking forward, we'll be talking about explore mode. So when you switch, the robot explores the room autonomously without you having to drive it around. In lifelong mapping, the current best practices is you create your map, you save your map, and then you navigate within the static map. You don't keep your mapping running because of accumulated error, and if the robot runs into something, it screws up the map. But eventually we'll get to lifelong mapping and the GPS or the explore mode. GPS, I think GPS is underrated. I think it's a great sensor to have into any robot. Fiducial markings. Alan Fetterman, one of our co-authors, he's kind of an expert in fiducial markers. He says put an arm on it. I says it's out of scope for this book. You work on it. So anyways, you want to talk about Dockers and AI and that sort of stuff too. That's kind of it for the presentations or the question. Am I muted? No, I'm not muted now.
Nope, you're not muted, and we got about 5-10 minutes left. So do folks have any questions?
That was honestly very fascinating, and thank you for walking us through it. Especially how you brought up scope. Because I've noticed scope creep seems to be a big problem for pretty much anybody, let alone small crafters.
How so?
The exact thing you just talked about, where your buddy was like, put an arm on it, is the exact thing that most of people go like, oh yeah, we should just start giving a leg.
We talk about MVP, minimal viable product. And so, yeah, and in fact, I like Lino Robot further out because I'm of the opinion you're not going to be able to get this smart table to do, with 3-inch wheels. I think you need 5-inch wheels. And Lino Robot, if you guys aren't familiar with Lino Robot, that's a really good model. One time in the mailing list, we were talking about making a standard ROS model for the Homebrewed Robots. And there was a lot of great links that went up and this and that and the other. And at the end of the day, it occurred to me that if we were to create a standard ROS-based robot for the Homebrewed Robotics Club, Lino Robot is what that should be. So the Lino is Tagalog for intelligence. And this fellow, Juan Miguel, is in Singapore, and he runs the hub. But Lino Robot, Lino Robot, Lino Robot 2 is a good model. Let me try and do a quick little live demo here. I would actually do mapping and navigating, but frankly, I'm at wit's end. I'm having trouble when I launch SLAM Toolbox and the localization package. It's masking out my scans, and I've gone from 5G gateways to routers to phone hotspots. And anyways, if you're interested in some ROS troubleshooting, log into our ROS discussion groups on Tuesday. But let me try and get a quick little demo in here if I can. So the book, there's a PDF on the chat there. So you've got a free copy. Otherwise, at the top, you can buy it through Amazon. It's called Homebrewed Robots. Incidentally, anybody interested in writing a book, I'd recommend the Kindle Direct Publishing. You write the book, you upload it in a PDF, you put a retail price on it. It has a cost. You can buy it reasonable cost if you're just trying to do something for your club or your family or something like that. But people order it and they subtract the cost from your selling price and just send you a 40% royalty check. So if you're interested in writing a book, do it through Amazon. And you've got a PDF of it up there, which is actually better because you can click on the links and stuff. Let's see here. Do I have that? Let me share my screen one more time. So this is with a ROS workstation. You've installed Ubuntu, you've installed ROS, and this just really gets at the basics of ROS, just a quick little demo. Actually, let me go all the way to the top. Boom. Okay, right there. Okay, so this is the ROS 2 tutorials. Okay, and so I'm going to open up a terminal window here, and I'm going to go ROS 2 node list. This shows me all the nodes that are running for ROS, and there aren't any nodes running right now. Okay, and so let's go ROS 2 topic list, and so just by running ROS topic list, you get parameter events in ROS, but there aren't any other ROS topics running. Okay, so let's do something here. Let's launch the Turtle Sim. Okay, this is the subscriber. This is a subscriber package. Okay, it brings up this little turtle screen, right? Let me open up another terminal window because you can't open enough terminal windows, right? And let's do the ROS 2 node list again. So here you can see Turtle Sim is running, ROS 2 topic list. Okay, so the ROS 2 topic list shows us something called command velocity here. Okay, that's a subscriber. Okay, actually that's a see here that let's do this. Let's do ROS 2 topic. I'll do this topic. ROS 2 topic. Let's try that. ROS 2 topic info. Verbose. Here we go. And so here it's telling us about this topic. It's telling us it's being published by Turtle Sim. Okay. And so, okay. So here's Teleop Keyboard. This is actually a publisher. Interesting. I thought that might have been subscribing, but this is a publisher that you can publish to the topic command velocity. Let's, okay, that's the Turtle Sim. Okay, let's look at the info for this again. And okay, so it's basically information on that is, okay, it is a subscriber. Okay, so the Turtle Sim is the subscriber. Teleop Keyboard is the publisher, but we have not published anything yet. Let's get that turtle up here. Okay, so there's the turtle. I'm going to hit the keyboard. Okay, you see me driving the turtle around? Yes. Is this thing on? Yes?
Yep, looking good.
You see the
Yep,
turtle?
I can see it.
Let's look at information again here. And so now you have the publisher. Okay, publisher, teleop turtle. Okay, so let me come up here. Okay, so this was ROS 2 topic. Okay, so we're looking at command velocity. And you see Turtle Sim is the subscriber. And you see that teleop turtle is the publisher. So I'm publishing command velocity, and the Turtle Sim is subscribing to it. And we can look at that here, and I'll be done with my demo. But so here is the subscriber. Here is the publisher. We can go to ROS 2 topic echo / Turtle Sim. Oh, Turtle 1 / command vel. Okay, and there isn't anything there right now until I start publishing. You see that? So here with teleop keyboard, I am publishing to the turtle topic. Okay, and when I press the forward arrow, you see the X forward, the X is 2. That's measured in meters per second. Okay, of course, this is just a simulation. But so I go forward and it's 2, 2, 2. I go backwards and it's -2. I hit the right and it's angular velocity, -2. You see the Z there? And the right, it's the 2. So I could go forward and I get positive linear velocity. I can hit the right arrow and I got -2 angular velocity. I hit forward, I got 2 on the forward velocity. There's 2 on the angular, and I'll go reverse. And there you see -2 on the linear. So the point here is ROS. This is a publisher. This is the subscriber. Here I can look at the topic and see what's going on. And I think I'll just stop it right there.
Okay, thank you very much.
You're very welcome.
Yep, we got time for one question if anybody's got one. Anybody have a question outstanding? I didn't think so. Okay. So I think we'll wrap it there. Thank you very much for presenting. That was great.
You're very welcome.
Does anyone want to hang out after the meeting ends and chat? I'll pass the host function to you. If not, I'll stop the recording and we'll call it a day.
Hey, Lloyd?
Yeah.
I could go on with some live demo stuff that's very likely to fail, but it's kind of interesting from a troubleshooting perspective.